Hello everyone, I'm Craig Boswell. Today on Interview 360, the first ever mission to the sun. New technology is allowing NASA scientists to send a spacecraft into orbit around the sun, traveling through its atmosphere, and potentially unlocking some of the mysteries to our star, the ultimate source of energy for all life on our planet. One of the many goals of the mission is to better understand solar weather, space weather, and potentially the ability to forecast space weather events that impact life on Earth. There is a lot to talk about, and here to navigate us through all of this is astrophysicist Dr. Eric Christian. Eric, what extraordinary times that we live in.
Thanks, Craig. This is great. I mean, this mission is so exciting. We've been working for many years. I mean, this is actually the mission to the sun is one of the first missions that NASA back in 1960 wanted to do. And only now do we have the technology so that we can actually go to the sun, go within 4 million miles of the surface of the sun.
So it's the technology now that has caught up with the dreams
that's
allowing this mission to happen.
So one of the things that allows us to do this mission is we have a heat shield, what's called a thermal protection system, 4.5 inches thick and made out of carbon fiber on the sides and the carbon foam in the middle. In this, we keep between the sun and the sensitive parts of the spacecraft. I like to joke that my instrument hides in the shadows behind this big heat shield and stuff because the sun is just too bright. On the front side of this heat shield, it'll be hot enough to melt aluminum, 3,000 degrees Fahrenheit. And yet on the back side, it'll be 200 degrees Fahrenheit. And by the time you get to the main part of the spacecraft, it's down to 75 degrees Fahrenheit, room temperature.
Room temperature, so that all of the instruments protected by what, roughly 5 inches?
4.5 inches, yep.
Once it launches, how long before you're getting into the first pass of the sun, or how long before you get to that within 4 million miles?
So on the first one, we'll go past Venus about a month after we launch, and then we'll use Venus and we'll get to within 20 million miles. Then we come back, and 3 orbits later, we get to Venus again. That's about a year later, and use Venus to shed more velocity. You actually have to lose speed in order to get into the sun. It seems weird, but you have to lose speed because otherwise you're in orbit the way the Earth is around the sun. And so every year we'll use Venus to get closer and closer. And over 6 years, then we get into the closest approach, which is 4 million miles. So the sun is the most important star in the sky. But there are basic things about it we don't know. And there are 3 basic questions that Parker Solar Probe will allow us to answer. One of them is, why is the atmosphere of the sun, what we call the corona, hotter than the surface of the sun? Normally when you move away from a fire, you get colder.
Right, counterintuitive. Right?
Yeah, it's completely counterintuitive to get further away from the heat source, which is the sun, and get hotter.
Wow, okay. The other questions that you want to solve?
So the sun throws a solar wind out in all directions. These are particles, atomic particles, blowing in all directions. It's what causes the tails of comets. We don't know what accelerates that gas out to 1 million miles an hour. That's another one of the questions, that by going there to where that solar wind is being accelerated, where it's getting sped up, we can find that out. And then the third question is, there are particles coming from the sun that are moving at almost the speed of light, what we call solar energetic particles. They come from solar flares and the really big explosions, coronal mass ejections on the sun. And they're the ones that are most dangerous to our astronauts, our spacecraft here at Earth. And so understanding how they are created is the third important question.
I should mention that this probe, this spacecraft, has a particular name, which is another first for NASA, right?
So this is called the Parker Solar Probe after Eugene Parker, and it's the first time NASA's named a spacecraft after a living person. Gene Parker, before any spacecraft were launched, figured out that there was a solar wind, and he used comet tails and came up with a theory that when we got spacecraft out there, turned out to be almost exactly correct.
It's got to be humbling for you, because I suspect while you have these answers, you have these questions that you want answers to, you may not get those answers. You may discover that we actually know little to nothing, and we just have more questions than answers than when we first began, right?
Well, every time we've been to someplace new in the solar system, we've been surprised. Every single time.
Look, thank you for breaking down all of this for us, explaining that to us, and keep us updated.
I will. When we get our first science results, I'll come back and tell you all about it.
Appreciate that. And we will keep you updated as well. Thank you for watching. This is Interview 360.